So now that we've defined graphs and given some simple examples, let's take a minute to just go over some nice applications of graph theory. So like I said, graph theory has an immense number of applications. So there's a lot of things you could put on this list, and you can go and find more examples for yourself if you're interested. But here are some things that you will be very familiar with that are essentially, whether or not you've thought about them in these terms before, are essentially graph theory problems. So social networks are, sort of the quintessential example of graphs. So social networks can be modeled as graphs. And this is important for, operating social networks. So, for example, you may have seen things like suggested friends on Facebook, or, you're getting suggestions of things to follow on all sorts of other social networks. And things like this is essentially a graph theory problem. Because how can we state this in terms of graph theory? So we take a graph that is sort of coming from real-world data, and the problem is to predict missing edges in your graph, which in this case corresponds to people who know each other but are not connected on Facebook. So essentially, the way you work with this problem is that you have this big graph of friend connections on Facebook, and you're looking at the structure of this graph and trying to decide if there are any edges that exist in sort of the real world that are missing from your graph. And of course, lots of other things go into this as well, besides purely the structure of the graph, but that is a big part of it. And there's many other applications in data science and machine learning and these kinds of topics for finding missing edges in graphs. So that's one nice application. Another, computer networks can be modeled as graphs. And for example, of a problem that comes up in this context, you are listening to me talk over the internet right now, but there is no direct line from my computer, where I'm saying these things, to your computer where you're hearing them. So essentially, the way that's working is that this information, this data, has to find its way through a huge graph. So finding the best path through the network is, again, this is essentially a graph theory problem. which again, has many other components besides the pure graph theory of it, but at its foundation, it is trying to find some kind of optimal path through a graph. That is how you model routing internet traffic, for example, from one computer to another. And then maybe one last example, transportation networks. Can, of course, be modeled as graphs. So, for example, whatever, your airline of choice, Southwest Airlines, does not serve every airport in the country. Basically, they have to make these choices. They have to choose which routes to fly with their planes and how often, and basically making these choices of how to set up their network of routes and flights is essentially, again, a graph theory problem. Because essentially you have this big network or this big graph of transportation hubs and connections between them, and you're trying to choose sort of a sub-network, or you're trying to make a choice of edges and nodes to service to get the most connected with the least cost, things like this. So all of these things and many, many more are places that graph theory shows up in real life. And if you're looking for whatever examples in your own field of interest, I'm sure you will find some.